Hi everyone, my name is Zandile and welcome to Finance. Please don't skip this intro as it is very important. This video covers everything that you need to know to get a minimum of 60% and above in this section of the paper. It is very important that you watch the video in order. Why? Because as we move along, we're going to come across some concepts that I've already explained earlier in the section. So I won't be going deep into them again. They've already been broken down properly before. So there is no need to repeat as already I've explained it in a deeper sense. Now, if you're currently sitting below 50%, I highly recommend that you start with Solve for X, not because I want to discourage you, but because this section is foundational. And if you understand Solve for X, trust me, everything is going to be easier. And again, in this video, if we come across anything that is related to Solve for X, I'm not going to go deep into it as I'm going to assume the fact that you already know the knowledge. Hope that makes sense why it's very important to basically start with Solve for X. And again, Solve for X is a foundation of every topic because you're going to come across it in every topic that we're going to do from now on, right? Now, the video breakdown. The video is going to be divided into 3 sections, which is section 1, interest rate calculation, section 2, value over time, then section 3, financial applications. This video is pretty long, so to help you out, I've added timestamps in the description. You can use them to jump to specific parts if needed. Again, right? Just very important. Only use it to jump into sections if you already know the fact that the previous sections you already understand. If you don't understand, make sure the fact that you go in order. As I said, the fact that everything is a build up. Hope that makes sense, right? So with that said, we can start with the video. Welcome to finance. So the first thing that we're going to start with simple interest, right? And this is the formula for simple interest, where A is the accumulated amount, which this amount is always the highest amount, right? So this is the highest amount, right? And we have the principal amount. This one is the lowest amount, right? Then we have interest, which is decimal form, meaning we take the interest and divide it by 100. That's what it means, right? To get the decimal form. And we have the number of years, right? So let's just get in and do the first example, right? So this one, we determining the accumulated amount, meaning we determining A, right? So it says Karina deposit 1,000 into a special bank account, right, which pays a simple interest rate of 7% per annum, right, for 3 years. How much will be in the will be in our account at the end of the investment term? So we need to calculate A. So let's write all the given information. We see the fact that we have P, right, which is 1,000 rand, right? Then we have what? We have I, which is what? Which is 7%. But remember that we need to change it. So it's going to be the same as 7 divided by 100, which is going to give us what? Which is going to give us 0.07. So it's 0.0. Made a mistake. It's 0.0. So 0.07, right? Then we have N, which is N is going to be equals to what? It's going to be equals to 3. Then we have A, and A is the one that we're looking for, right? So now we're going to use this formula to basically calculate our accumulated amount. So it's going to be A is equals to P, open bracket, 1 plus I, right? Multiplied by N. So this is going to be multiplied by N. I forgot N. Sorry about that. So this is going to be multiplied by what? Not this one. So this is going to be multiplied by N, right? So it's going to be A is equals to what? What is our principal amount? It's 1,000, right? Then we're going to have 1 plus in decimal our interest, which is going to be 0.07 multiplied by N, which is 3, which is the number of years, right? Then you punch that into the calculator, you're going to get that your A is going to be equals to what? to this amount, 1,210. So this is going to be the amount that's going to be in the account at the end of the term. So now we're going to do example 2, where we are given the accumulative, right? We are given the interest and we're given the in, but we're not given what? The principal, and we're looking for the principal amount, right? It says a bank offers a savings account which pays a simple interest, right, at the rate of 6% per annum. If you want to accumulate 1,500, if you want to accumulate 15,000 in 5 years, how much would you have to invest, right? So we know the fact that we have A, we have P, right? We have I, then we have N, right? So we know the fact that they gave us the accumulated amount, which is what? Which is 15,000, right? We're looking for the principal amount because that's the amount of money that we need to invest now, right? Then we have our interest. Our interest is 6%. Change it, which is going to be the same as 6 divided by 100, which is equals to 0.06, right? Then we have N, which is 5 years, right? So we're going to use our formula, which is A is equals to P, open bracket 1 plus I, N. Substitute everything that we have. We are given the accumulated, right? We're looking for P. So it's going to be P, then it's going to be 1 plus, then it's going to be 0.06. Multiplied by what? Multiplied by 5, right? So it's going to be 15 here, right? Is equals to what? P. Then punch this into the calculator. You're going to have that being equals to what? To 1,3. Everything that's in the bracket, right? Divide both sides by 1.3. So it's going to be 15,000, right? Divided by what? By 1.3 is equals to P. Punch this into the calculator, you're going to get that your P is basically equals to this amount, which is going to be 11,538, right? Comma what? Comma 46. And that's how you would determine the principal amount if you're given everything besides the principal amount. Example 3, right? It says, at what simple interest should Farida invest if she wants to grow 2,500 to 4,000 in 5 years, right? So what do we see? We see the fact that we are given everything, but we need the interest, right? We are calculating the interest, right? So we see the fact that we have A, we have P here, right? We have I, then we have N, right? Remember I said the fact that the highest amount is always the accumulated. So 4,000 is going to be A, then 2,500 is going to be what? It's going to be P, right? We are looking for what? We are looking for interest. Then the amount of years is 5, right? So we're going to use our formula. So it's going to be like this. 1 plus I multiplied by N, right? So now we're going to substitute everything we have. So it's going to be 4,000 here is equals to 2,500. Right? Open bracket is going to be what? It's going to be 1 plus. Then our interest is the one that we want, multiplied by 5, which is the number of years, right? So now we're going to make I the subject. So it's going to be 4,000 divided by 2,500, right? Which is going to be equals to what? Which is going to be equals to 1 plus I multiplied by 5, right? So simplify this. When we simplify it, we're going to get the fact that it's going to be 1,6 is equals to 1 plus I. So this is going to be I, sorry about that. So this is going to be I multiplied by 5, right? So when we take the 1 to the other side, it's going to give us 0.6 is equals to what? To 5I, right? Then divide both sides by 5. So we get the fact that it's going to be what? It's going to be 0.12 is equals to I, right? When we divide both sides by 5, right? After doing that, I'm just going to change this into being a percentage. So it's going to be 0.12 multiplied by 100, which is going to be equals to I. So therefore, I is basically equals to 12%. So our answer here will be 12%. So example 4 says, Tata deposits 30,000 into a bank account that has a simple interest of 7 7.5 per annum, right? How many years must he invest for it to generate 45,000? So what do we see? We see the fact that we're looking for how many years, so we're looking for N, right? N is the one that's missing. So we have that, we have A, we have what? We have P, right? Then we have I, then we have N, right? So let's fill in the information. I said the one with the largest amount is A, so it's going to be 45,000, right? Then it's going to be what? It's going to be 30,000 for the principal amount, right? Then I, it's going to be 7.5%, right? Which we're going to change it, which is going to be 7.5 divided by 100, which is going to basically give us what? It's going to give us 0.075, right? Then we're looking for N. Substitute everything, so we're going to have A is equals to P, open bracket 1 plus I, N, right? Substitute everything that we have. So it's going to be 45,000, right? Is equals to 30,000, right? Open bracket, we're going to have what? We're going to have 1 plus what? 1 plus 0.075, right? Then that's going to be multiplied by N, which is the one that we want, right? So now divide by 30,000, so it's going to be 45,000 divided by 30,000, right? It's going to be equals to open bracket 1 plus 0.75 multiplied by N, right? So now this is going to become what? Going to basically become 1.5 when you simplify that. And this is going to be 1 plus 0.7075 multiplied by N, right? So take the one to the other side. So you're going to have 0.5, right? Is equals to 0.075 multiplied by N. Divide both sides by 0.075. So it's going to be 0.5 divided by 0.075 is going to be equals to N, right? Therefore, N is going to be equals to what? Plus that is going to be 6.7, right? Meaning now we always round up, right? So it's going to be what? It's going to be equals to 7 years. Because there is no such thing as 6.7 years. So it's going to be 7 years. So we always round up, right? So even if it was 6.2, then we're going to say it's going to be what? It's going to be 7 years. Regardless of what it is, we always pick the next number after the one that's in front, right? I hope that makes sense. So now we're going to talk about the nominal and effective rate, right? And here we're basically introducing the idea, honestly, here they're introducing the idea of this. As you will see when we do compound, or if you have seen like questions about compound, like what you call this compound interest, right? Is that they would say compounded annually or yearly, or the half yearly thing, or the quarterly, the monthly, and the weekly and the daily. That's what we're introducing here, right? It's just changing the formula of the compound interest and putting it to being maybe monthly, yearly, quarterly, or daily, right? So now with that said is that if they say compoundingly annually, right, or yearly, and let me just write the yearly here, because yearly, it means the fact that from your formula, right, here, you need to divide by 1 and also the whole thing needs to be a power to the 1, right? Then when they say half yearly, right, it means the fact that now this M is going to be a 2, and this is going to be a 2. Same applies with quarterly, is going to be 4. What you call this, monthly, it's 12. Weekly is 52. Then daily is 365 days, right? So this is what it means. It means the fact that when they say annually, you need to know what we divide them by. When they say half yearly, you need to know and it can be half yearly, and here it can be semi-annual here, right? At the half yearly. Semi-annual, right, and half yearly is the same thing. It means the fact that you need to divide by 2. I hope that makes sense, right? So that is the idea that you need to understand. So now let's do an example where we determine the effective rate and we are actually given the nominal rate, right? So the nominal rate is going to be the one that we given here. So this one, right, is considered as the nominal. So this following ones are considered as nominal, and the effective rate, right, is going to be used by calculating this I from this formula, right? So let's do the following, right? So for the first one, right, so for A, right, it says what? Determine the effective annual interest rate if the nominal rate is the following. So we see the fact that here it's 12%. So we see the fact that I to the power m, right, is basically equals to what? To 12%, right? So we see the fact that it's equals to 12%. Then we see the fact that m here, it says compounded annually. So it's going to be what? It's going to be 1, right? Because annually and yearly is the same thing, which is going to be 1. So here we're going to use our formula. So it's going to be what? This is the formula. So it's going to be 1 plus, then it's going to be I. And this I here, it's considered as the effective rate. And this is going to be equals to what? This is going to be 1 plus, then it's going to be I, then it's going to be m here, right, divided by m. Then this is to the power m, right? So here, let's substitute 1 plus. Remember the fact that this is the one that we're looking for, right? So it's going to be 1 plus, right? So this one is going to be what? It's going to be 12%. So let's change it. It's the same as 12 divided by 100, right? And this is going to be what? This is going to be 0.12, right? So it's going to be what? It's going to be 0.12 divided by what? By m, which is 1 to the power 1, right? Paste this, what you call this, before you paste this to the calculator, take the 1 to the other side. So it's going to be 1 plus 0.12 divided by 1, right? And to the power 1, then this is minus 1. Times that to the calculator, you're going to get the fact that you're going to have 0.12, right? So when we have 0.12, therefore I, when we multiply this by 100 to get a percentage, I, the effective rate, is going to be equals to 12%. So that's how you would find that one, right? So now let's do B. It says the effective rate, right? So we see the fact that the effective rate, the nominal rate, sorry, is equals to what? Is equals to 14.5%. Let's change it into decimals. So it's going to be 14.5 divided by 100, right? So this is going to be basically what? This is going to be basically 0.145, right? And we see that m is given as what? M is given as half yearly, meaning m is equals to 2, right? So let's substitute. So when we substitute, it's going to be 1 plus, then it's going to be I, which is the effective rate. Then this is going to be what? Open bracket is going to be 1 plus, then it's going to be 0.145 divided by what? Divided by 2, right? Then this is going to be to the power 2. Take the 1 to the other side, so therefore I is going to be basically equals to 1 plus 0.145 divided by 2. Then this is going to be to the power y to the power 2, but minus 1. Pass that to the calculator, you're going to get that your effective rate is going to be equals to 0.15, right? Then change this into what? Into a percentage, so it's going to be multiplied by 100. So therefore, I is basically equals to 15%. So that's how you would find B, right? So now let's do C, right? So with C, it says what? It says I, the nominal rate, which is I to the power m, right, is basically equals to 31%, which is the same as 31 divided by 100, which is going to be equals to what? Which is 0.31, right? So that is what? That is our nominal rate. So with that being our nominal rate, right, now we know the fact that this is compounded what? Monthly, meaning it's going to be, m is going to be equals to 12, right? So we know that m is equals to 12. So now with m being equals to 12, let's put everything into the formula. So it's going to be 1 plus I, which is what we want. The open bracket is going to be 1 plus. Then this is going to be what? 0.31 divided by what? Divided by 12 to the power 12, right? Take the 1 to the other side. I is going to be equals to what? To 1 plus 0.31. So this is 3, 1 divided by 12 to the power what? To the power 12 minus 1. Punch that into the calculator. You're going to find that your I is going to be equals to what? It's going to be equals to 0.36, right? Then this is going to be multiplied by 100. So therefore, I is basically equals to what? Is equals to 36%. So that's how you would find C. So now we're going to do D, right? So with D, we see the fact that I to the power M, right, which is the nominal, is given as what? It's given as 9%, right? So that is going to be given as 9%. Change that is going to be 9 divided by 100, which is going to be equals to 0.09, right? So now we're given the fact that this is compounded what? This is compounded weekly, right? Weekly means what? It means the fact that M is basically equals to what? Is equals to 52, right? So now let's substitute everything into the formula. It's going to be 1 plus I, which is the effective rate where we're looking for, is equals to what? Is equals to 1 plus, then it's going to be what? It's going to be 0.09, right? Divided by what? Divided by 52, right? And this is going to be to the power of 52, right? Take the 1 to the other side. So I is going to be equals to what? It's going to be 1 plus 0.09 divided by 52. And this is going to be to the power of 52. And this is minus 1. Punch that into the calculator. You're going to get that your I is going to be equals to 0.094, right? Multiply that by 100 to get it into being right, to being a percentage. So I is going to be equals to 9.4%. So that's how you would do D, right? So now doing E is going to be what? It's going to be the E, the nominal rate, which is I to the power M, right, is basically equals to 25%, right? Which is the same as what? As 25 divided by 100, which is going to be equals to what? Which is going to be equals to 0.25, right? So M here is going to be equals to what? 2, this is compounded daily. So this is going to be divided by what? This is going to be, M is going to be what? Sorry. M is going to be 365, right? So now substitute everything into the formula. It's going to be 1 plus I, which is the effective, what we're looking for. Then this is going to be 1 plus, then this is going to be what? This is going to be 0.25 divided by what? Divided by 12, right? Divided by 365, because that's M. Made a mistake there. So this is going to be divided by what? This is going to be divided by 365. And this is to the power 365, right? And this is minus 1. I took the 1 already to the other side. So let's just do... I don't want to confuse you guys. So let me just erase that. Then now what I'm going to do, I'm going to take the 1 to the other side. So it's going to be I. Then this is going to be what? This is going to be 1 plus 0.25, right? And this is going to be divided by 365 to the power 365, right? And this is minus 1. Therefore, I, when you punch it into the calculator, you're going to get it as being what? 0.28 multiplied by 100. Therefore, I is basically equals to 28%. And that's how you would find I. Now we're going to move to compound interest, right? And I said the fact that the reason why they introduced the nominal and the effective rate, it was just to rearrange or give this new compound interest formula the M, right? So now our question is going to contribute what, whether it's compounded annually, half, yearly, right? Quarterly, monthly, weekly, or daily. So it's going to appropriate this words, right? And that word means the fact that you need to divide your interest rate by what? By the annually, half yearly, quarterly, monthly, whatever that they give you. Then you also need to multiply your number of years by that, whatever that they give you, right? So now let's take a look at the first example, right? It says Karina deposits 1,000 Rand, right, into a special bank account which pays 7% compounded half yearly, right, for 2 years. Then it says how much will be in the account at the end of the investment term, right? So here we see the fact that A, we have P, we have I, then we have N, right? So what do we have? We know the fact that she deposits 1,000. So P is going to be 1,000 because that's the initial amount that she deposits. A is going to be the one that's missing because that's what we want at the end of the term, which is the final amount, right? Then I, right? The interest rate is what is 7%, but it's compounded It's compounded, half yearly. So here, what do we need to know? We need to know the following. We need I and we need M2, right? So we see that M is equals to what? This half yearly, so it's going to be 2, right? So I is going to be divided by what? It's going to be divided by what? It's going to be 7% divided by 100, which is going to be equals to what? To 0.07, right? Then N is going to be what? It's going to be 2 years. But remember the fact that it needs to be multiplied by what? It needs to be multiplied by M, right? But let's substitute everything into the formula so I don't confuse you guys. So it's going to be A is equals to P, right? Then this is going to be 1 plus this is going to be I to the power Y to the power M, which is going to be I divided by M to the power N multiplied by M. That's what I meant. Then now let's substitute everything. So it's going to be A, which is what we're looking for. Then P is 1,000, right? Then this is going to be 1 plus our percentage is 0.07, right? And this is going to be divided by what? Divided by 2 because that's M. And this is to the power Y to the power 2, which is N, multiplied by 2 again because that's M, right? So now let me just simplify everything. So this is the same as 1,000, right? This is 1 plus, then this is going to be 0.07 divided by 2, and this is to the power 4, right? Punch that into the calculator, you get that A is going to be equals to what? A here is going to be equals to the following. It's going to be equals to 1,400 and it's going to be 1,147,52. And that's how you would find your accumulated, this amount. So now let's do example 2 where we're determining the principal amount, right? So P is going to be the one that's missing, right? So it says a bank officer's savings account which pays 6% per annum compounded yearly, right? If you want to, it says if you want to accumulate 15,000 in 3 years, how much should you invest, right? So now we're looking for P. So we know the fact that we have A, P, I, and N, right? Write down the information that we have here. So we know the fact that A is going to be the 15,000 because that's the money that we want to accumulate. That's our goal. That's the final amount. P is the money that we need to invest now. We don't know how much it is. Then here, remember the fact that we also have M. So I is going to be equals to what? Our I value here is going to be what? It's going to be 6. So it's going to be 6 divided by 100, which is going to be the same as 0.06, right? Then N here is going to be what? It's going to be 3 years. And our M is compounded yearly, so it's going to be equals to 1, right? So now we have everything. So let's substitute everything we have. We know that A is equals to what? To P, open bracket, 1 plus I to the power M to the power M multiplied by N, right? So now let's substitute. It's going to be A. A remembers what they gave us, so it's going to be 15,000 is equals to what? Is equals to P. Then open bracket, it's going to be 1 plus, then it's going to be 0.06, right? Divided by what? Divided by 1 to the power what? To the power 1, which is M multiplied by what? By 3, right? Punch, or we can punch that into the calculator. Then what we're going to do here is going to be 15,000 divided by this whole term here. So it's going to be 15,000, right? Divided by what? Divided by 1 plus what? 1 plus 0.06, because this is going to be just 0.06, and this is to the power 3, and this is going to be equals to P, right? So therefore, P is going to be equals to what? Punch this whole thing into the calculator. You're going to get that P is going to be this amount. So it's going to be 12,000, right? 500 and what? 594.29. So this is the amount of money that they need to invest initially so that they can get what? They can get 15,000. So now let's do example 3, right? It says Gabby deposits 30,000 into a bank account and pay 7.5% per annum compounded half yearly, right? It says how many years must he invest for it to generate 45,000, for it to generate. So I think the it is missing there, right? So we have what? We see the fact that we need to know how many years, meaning we're looking for what? We're looking for the number of years, right? So it's going to be A, it's going to be P here, right? It's going to be I, then it's going to be N, then it's going to be M, right? So let's substitute everything we have. A is going to be 45,000, the highest amount. Then here is going to be 30,000, right? So it's going to be 30,000. Then I here is going to be 7,5 divided. I'm just going to divide it by 100, which is the same as 0, 0, right? 0,075, right? Then N here is going to be what? Our N is what we're looking for. Then M is what? Is compounded half yearly, so it's going to be 2, right? So let's substitute everything that we have. We have A is equals to what? Is equals to P, open bracket 1 plus I to the power what? To the power M divided by M to the power N multiplied by. So it's going to be N multiplied by M, right? Substitute everything. So it's going to be what? It's going to be 45,000 is equals to 30,000, right? Open bracket is going to be 1 plus, then this is going to be what? It's going to be 0,075, and that whole thing is going to be divided by what? Divided by 2. Then it's going to be what? It's going to be N multiplied by 2, right? So now it's going to be what? It's going to be, take the 30,000 to the other side, so it's going to be 45,000 divided by what? Divided by 30,000. Right, and this is going to be equals to what? It's going to be equals to 1 plus, then this is going to be 0,075, right, divided by 2, and this is going to be to the power 2n, right? So now you're going to simplify this one there, 45,000 divided by 30,000, which is going to give you 3,2, 3 divided by 2, right? And this is going to be what? This is going to be 1 plus what? 1 plus 0,075 divided by 2. Since whatever we want is an exponential, we need to use log. So it's going to be 2n here because it's going to go to the other side. Then we're going to have log, right? What is our base? Our base is going to be this whole thing. So it's going to be 1 plus what? 1 plus 0,075 divided by 2. Then this is going to be what? This is going to be, this one is going to be next to the log. So it's going to be 3 divided by 2, right? So now let's paste the log part inside the calculator. So you're going to say log, then it's going to be 1 plus, then it's going to be fraction 0,075. Then this is going to be divided by what? Divided by 2. Then this is going to be 3 divided by 2, right? Which is going to give us what? Which is going to give us 11. So 2n here is going to be equals to what? It's going to be equals to 11, 0, 1. Yes, it's going to be 0, 1, right? Divide this by what? By 2. So n is going to be equals to 11.01 divided by 2, which is going to give us the following. So it's going to be 5,505, right? So now n is approximately, always round up, so it's going to be equals to 6 years. So answer here is going to be 6 years. So now let's do example 4, right? It says, at what compound half-yearly interest rate should Lisa invest if she wants to grow 2,500 to 4,000 in 5 years, right? So let's write everything that we need here. So we know the fact that it's A, it's P, it's I, then it's N, then it's M, right? So we know the fact that the highest amount, which is 4,000, is going to be A. Our principal is going to be the 2.5, right? Our I here is what we want. Then they tell us the fact that N is what? It's 5 years. Then they tell us the fact that this is compounded what? Half yearly, so this is going to be 2, right? So now substitute everything. So we're going to have the following. We're going to have, this is half yearly, right? So it's going to be A is equals to P, open bracket is going to be 1 plus I divided by M to the power N multiplied by M, right? So let's substitute everything. So we know the fact that's going to be 4,000 here is equals to 2,500 here, right? And open bracket is going to be 1 plus I is what we're looking for. And that's going to be divided by what? That's going to be divided by 2, right? And this is to the power y to the power n, which is going to be 5 multiplied by 2, right? So now we're going to divide by 2,500. So it's going to be 4,000 divided by 2,500, right? It's going to be equals to what? It's going to be 1 plus I divided by 2. Then this is going to be what? 5 multiplied by what? By 2. So it's going to be 5 multiplied by 2, which is going to give us 10, right? Then now we're going to just simplify the 4,500. So it's going to be the 4,000, right, divided by 2,500, which is going to give us what? Which is going to give us 8 divided by what? Divided by 5. And that's going to be equals to what? It's going to be 1 plus I divided by 2. Then this is to the power 10, right? So now we're going to, we're going to 10 root both sides to get rid of this power 10. So it's going to be like this to the power 10. So it's going to be like this. And the side is going to be the same thing because we want to get rid of this power. So it's going to be 1 plus I divided by 2, right? So now when you do that, when you do to the 10 root, right? So you're going to get the following. So when you say A divided by 5, right? You're going to get the following. You're going to get the fact that it's going to be 1 comma what? 1,048, right? And the side's going to be 1 plus I divided by 2, right? So now what you're going to do is you're going to take the 1 to the other side. So you're going to say what? You're going to say this whole thing minus 1, which is going to give you what? Which is going to give you 0,048 is equals to what? To I divided by 2, right? So you're going to multiply this by 2, the 0, so you're going to say 0,048 multiplied by 2. Therefore, you're going to have what? You're going to have 0,096 is equals to I. So multiply this by what? By 100 to get into being what? To be a percentage. So it's going to be multiplied by 100. So therefore, I is going to be equals to what? So it's going to be multiplied by 100. So I is going to be equals to 9,6%. So that's how you would get your I to be equals to what? To 9,6%. So now we're going to move to simple and compound depreciation, right? So these are the two formulas and these are the two important words that you need to keep in your head, right? The minute they say the fact that determine what? Determine the depreciation using a straight line. Remember the fact that this is the formula that you need to use when they're talking about depreciation, right? And when they say the fact that reducing balance, right? Finding the depreciation, meaning the value of something going down, right? Is that this is the formula that you're going to use, right? Since I said the fact that it's the value of going down, depreciation is calculating the value of an item where it lost its value, right? That's depreciation. That means the fact that A is going to be the low amount and P is going to be the high amount. Remember the fact that the value is going down, right? So even here, A is going to be the low amount because the value at the end of whatever period after 5 years is when the value went down. So the value can't be high. It needs to be low, right? Then P needs to be the high amount. I hope that makes sense, right? So with that said, let's do our first example, right? This one is using a straight line depreciation. It says Harry wants to buy his grandpa a donkey for 800. His grandpa is quite pleased with the offer, seeing that it only depreciated at the rate of 3% per year using a straight line. Very important here, they say the fact that using what? Using a straight line method, right? Grandpa bought the donkey 5 years ago. What did Grandpa pay for the donkey then? So we need to calculate how much did grandpa pay then, right? So what did they give us right now is that now Harry wants to buy the donkey, right? Now in the present time for 800, right? So we need to calculate the past event, the past amount, right? Meaning we're calculating what we actually looking for P here, right? I hope it makes sense. Is that now Harry wants to buy a donkey which cost 800 rand. So the present value, as we're speaking now, the donkey cost 800 rand, right? So now we need to calculate how much did grandpa, right, had to pay for the same donkey 5 years ago, right? Meaning the past was when it's the present value. I hope that makes sense, right? So now we have what? Let's write our information. We have A, we have P, right? We have I, then we have N, right? So 800 rand is going to be what? It's going to be our now our now value, right? Then P is what we're looking for in this question. Then our percentage is 3%, so it's going to be the same as 3 divided by 100, which is going to be the same as 0.03, right? And 5 years ago, we want to check how much did grandpa pay then, which is 5 years ago, so it's going to be 5, right? So now let's punch everything, let's put everything in the formula. So it's going to be A is equals to what? Is equals to P, open bracket, it's going to be 1 minus I. So it's going to be 1 minus I, right? Then this is going to be multiplied by N, right? Then this is going to be what? Substitute everything. So it's going to be 800 is equals to what? Then P is going to be what we're looking for. Then this is going to be 1 minus. Then our interest rate is 0.03 multiplied by 5, right? So now it's going to be what? It's going to be 800 divided by this part. So it's going to be 1 minus 0.03 multiplied by 5. It's going to be equals to P. Punch that into the calculator. You're going to get the fact that P is going to be equals to what? To 941.18 cents, right? So back then, the donkey actually cost, or if grandpa had to buy the donkey 5 years ago, the donkey would have cost 941 rand, 18 cents. So that's the amount that it would have cost 5 years ago. So it says, now let's do an example that deals with reducing balance, right? It says on January the 1st, 2018, the value of my Kia is 320,000, right? Each year after the car's value would depreciate by 20%. So we see the fact that the value of the car loses by 20%. What you call this 20% of the previous year. What is the value of the car in the January 1st, 2012. So we see the fact that the car's value, the person bought the car, right, on January the 1st, 2008, right? So we need to calculate how many years using those two things, right? So number one. So now let's write all the information that we have. We know the fact that we have A, we have P, right? Then we have I, and we have N. So here, since they want the value in the future, right? Meaning what? We're looking for what? We're looking for A here, right? So A is the one that we're looking for. Then, what you call this? Our P value, the car was bought for how much? For 320,000, right? So that's how much the car cost in 2018, right? So now we're looking for the value of the car in 2012. I hope that makes sense, right? So here I is equals to 20%. So it's the same as 20 divided by what? Divided by 100, which is going to be equals to 0.2, because that's how much the car decreases. Decrease meaning it decreased by value by 20%, right? In each year. Then N here is the one that we need to calculate. Remember the fact that we want the value of the car in 2012, right? And the car was bought in 2008, right? So we're going to check the years there. So it's going to be 2012 minus 2008, which is our years is going to be what? It's going to be equals to 4 years. So N is going to be 4, right? So now let's substitute everything. So it's going to be A is equals to what? Is equals to P. Open bracket is going to be 1 minus I to the power n, right? So we're looking for A because we're looking for the price of the car in 2012, which is in the future, right? So it's going to be what? It's going to be in 2008, it cost this amount, right? Open bracket is going to be 1 minus, then it's going to be 0.2 to the power y to the power 4. Punch that into the calculator, you're going to get that this is how much the car costs now. So it's going to be 100,031.72 rand. So this is how much the car cost in what? In 2012. So this is the value of the car in 2012. So that's how you would do this question, right? So now let's do number 2 of this question here. It says a machine costs 45,000 and has a scrap value, right, of 9,000, right? After 10 years, right, determine the annual rate of depreciation if it's calculated using the reducing balance method, meaning using this method, meaning using this formula. That's how you need to calculate it, right? So now let's write down all the information that we have, right? So we know the fact that we have A, P, I, and N. Let's go back and read the information, right? It says the machine cost 45,000 and the scrap value is what? Is 9,000 after 10 years. So the machine, right, cost how much? It cost 45,000, meaning the present value was 45,000, right? The scrap value after 10 years is what the machine costs now, which is 9,000, right? That makes sense. Then we know the fact that I is the one that we want because it says determine the annual rate of depreciation. Annual rate meaning it's I, rate is I, right? Then they tell us the fact that it took how many years? It took 10 years for it to go from 45,000 to 9,000, right? So now we know that I is the one that's missing. So let's substitute everything. So it's going to be A is equals to what? Is equals to P. Open bracket is going to be 1 minus I to the power n, right? Substitute everything that we have. So it's going to be 9,000, right? Is equals to what? Is equals to 45,000, right? Open bracket is going to be 1 minus. Then the interest is what we want. And this is to the power y to the power 10, right? So this is going to be 9,000 divided by 45,000, right? And this is going to be equals to what? To 1 minus I to the power 10, right? So this is the same as what? This is going to be the same as 0.2 is equals to 1 minus I to the power 10, right? Put the root of 10 here. So it's going to be root of 10 of 0.2 is equals to root 10. Then it's going to be 1 minus I to the power 10, right? So I'm just going to write it here, continue here, right? So this side is going to be what? It's going to be this side when you say root of 10. So it's going to be, I'm just going to leave it as the way it is because it's going to give me too many decimals. So I'm going to just leave it as 0.2 root of 10. Then here it's going to be equals to what? It's going to be 1 minus I, right? Take the 1 to the other side. So it's going to be root of 10 of 0.2 minus 1 is going to be equals to minus I, right? Punch that into the calculator, you're going to get the fact that it's negative 0.15, right? Is equals to what? Is equals to negative I. Since they both negative, it's the same as I is equals to 0.15. Multiply that by 100 because I want the percentage. So I is going to be equals to 15%. So that's how you would do this question. So now we're going to move to future values, right? So the thing that you need to understand with future values is that in the question, they talk about monthly payments. So if they're talking about something that you're making monthly payments of, you need to think about it's either a future value or a present value, which is we're going to do up the future value, right? So this is the formula for a future value. This is how it looks, where X is the monthly values, right? I is the interest rate that's written in decimals. N is what? Is the time period in years, right? M is what? It's either, as you know, annually, half yearly, quarterly, monthly, those things, right? So with understanding the formula now, let's do a question that talks about finding the future values. So the question says, Zanele decides to start a saving account for the future, right? at the end of each month, she deposits 900 Rand, right? So Zanele deposits 900 Rand into the account at the mutual bank, which earns 0.25% interest per annum compounded monthly, right? So the first question says, determine the balance of Zanele's account after 29 years. So now for the first one, let's write all the information that we have, right? We know the fact that this is the formula, so we're going to need to know what's X. In our case, X is what? Is 900 Rand, right? So let me write everything XI, then it's going to be N, then it's going to be M, right? So let's substitute. We know the fact that, let me just write the information, that's what I meant. Then our interest rate is what? Is it's 8.25, right? So it's going to be the same as 8.25 divided by 100, right? Which is going to be the same as what? Which is the same as 0.0825, right? Then N is what? It's after 29 years, so it's going to be 29. Then M is going to be what? This is compounded monthly, so this is going to be divided by 12, right? Then with that said, now let's put everything in the formula because of we're looking for how much, what is the balance, which is the balance is going to be F, right? So now we're going to substitute everything in the formula. So it's going to be F here. So I'm just going to say F is equals to what? Let me just write the formula. It's going to be X, open bracket, is going to be what? It's going to be 1 plus, and this is going to be I divided by M to the power Y to the power N multiplied by M. Then this is going to be minus 1, right? And this whole thing is going to be divided by what? It's going to be divided by I divided by M, right? So now with that said, let's substitute everything. So it's going to be 800 here, right? Then open bracket is going to be 1 plus our I is what? Is 0.0825. And that's going to be divided by what? By 12, right? And that's going to be 29, which is the number of years, right? Multiply by what? Multiply by 12, right? And that's going to be minus 1. And that whole thing is going to be divided by what? It's going to be divided by 0.0825. And that's going to be divided by 12, right? Therefore, F is going to be equals to, punch that into a calculator, it's going to be equals to this amount. It's going to be 1,000,000. So it's going to be 1,289. Then this is going to be 665.06. So this is the amount that Zanele is going to have at the end of 29 years, right? Then the second question says what? It says, how much money did Zanele deposit into the account over 29 years? So here is that how much did she deposit without the interest in it, right? So to calculate how much Zanele deposited, into the amount, the actual amount without the interest, is going to be the 900. So the total, so we're going to call it total deposit, right? So the money that she deposited is going to be equals to what? It's going to be 900, right? Remember, then that was deposited over a period of what? So this is going to be over a period of 29 years. But remember the fact that within the 29 years, it was deposited monthly, right? Meaning multiplied by 12, right? So it was 29 years, but in that year, every year, it was every month, right? So that is why it's multiplied monthly, because it was compounded monthly. I hope that makes sense, right? Plug that into the calculator. So this is the amount of money that she deposited. So it's going to be 313. Then this is going to be 200, right? Then number 3, it says what? It says calculate how much interest earned over the over 29 years. So the question is asking us to calculate what? To calculate from the money that she deposited, right? How much interest did she earn? So it's going to be what? It's going to be this future amount that she put into the investment minus the actual money that she deposited. Then the difference is going to be the interest, right? So it's going to be the total interest, right? It's going to be equals to F, which is the future amount, right? Minus what? Minus the total deposit. right? So punch that, it's going to be, future is going to be what? 1,000. It's not going to be 1,000, it's going to be a million. So it's 1,289, then it's going to be 665.06 minus what? Minus 3, right? 313, then 200. Subtract that, punch that into the calculator. This is the amount of interest that she made. 900,070. So this is the amount of interest that she made. So this is the amount of interest that she made. So this is the interest that she made after 29 years after depositing this amount. I hope that made sense. So now let's do example 2, right? Is future value but with immediate deposit. If you look at the first scenario, they didn't say that Zanele deposit the money immediately, right? But in this one, they're going to say that Simon starts the retirement and deposits it immediately. And when there is immediate, then your end value changes, you add by 1, right? So let's just read the question, right? It says Sam starts to save for his retirement, right? He opens an investment account and immediately, very important word, right? Immediately deposits 800 into the account, right? Then there's everything which earns 12.5, right, percent per annum compounded monthly, meaning it's going to be multiplied by 12, right? So then they say thereafter he deposits 800 at the end of each month over 20 years, right? Then they say the fact that what is the value of his retirement savings at the end of 20 years, right? So let's write all the information that we have, right? So it's going to be what? It's going to be X, right? It's going to be I, it's going to be N, then it's going to be M, right? Then F is the one that we're looking for, right? So X is going to be the monthly deposit, it's 800 Rand, right? I is going to be what? The percentage, which is going to be 12.5 divided by 100, which is going to be the same as 0.125, right? Then N is going to be what? That's where the immediately comes in. 1 represents the immediately. Then plus, we know the fact that over a period of 20 years, so it's going to be 20, right? So it's going to be 1 plus 20, right? Then here, I need to account, let me just do this, right? Because if they say immediately, I'm going to already account the monthly payment. So it's going to be 20 multiplied by 12. And the reason why I'm not going to do it in the formula, right, is that you might forget and basically what? And basically, and basically multiply the 21 by 12, and which will be wrong. So that is why I account for the M already in the N, right? So that it makes sense. So it's basically 20 years multiplied by the monthly, which is 12, right? Then plus 1 extra month because of he deposited immediately. I hope that makes sense, right? So M is going to be what? M, we know the figure is going to be 12. Then F is the one that we're looking for. So here it's going to be what? It's going to be 1, right? So it's going to be 1 plus 20 multiplied by 12, which is going to give us 241. So our Simon made 241 payments. So if he did not deposit it immediately, it was going to be, he made only 240, but we add into account the fact that he made an extra payment, right, immediately, which is going to be that 1 payment. I hope that makes sense, right? So we know the fact that here, if is going to be equals to what? It's going to be equals to X. Then this is going to be 1 plus I divided by M, right? Then this is going to be N multiplied by M. But this one, we already calculated it, remember? Then this is going to be minus 1. And this whole thing is going to be divided by I divided by M, right? So it's going to be F is equals to what? It's going to be X, which is going to be 800. Then this is going to be 1 plus, then the interest, remember, is going to be 0.125. Then this is going to be divided by what? Divided by 12, right? Then N is going to be the amount that we already calculated, which is going to be 241, right? And this is going to be minus 1, right? Then this is going to be divided by what? This is going to be divided by 0.0 0.125, and this is going to be divided by 12, right? So now what we're going to do, we're going to punch that into the calculator. So F is going to be equals to what? F is going to be equals to the following. It's going to be equals to this amount. So it's going to be 8, right? Then it's going to be 8. Sorry. So it's going to be 8,5. So it's going to be 8,5, 6. Then it's going to be 415, comma what? Comma 66. So this is the amount of money that he would have made after 20 years. So I hope this question makes sense. So now let's do what? Let's do example 3, where we're determining the monthly payments, right? It says Riri is planning a trip to Canada to visit her friend in 2 years' time, right? She makes an itinerary for her holiday and expects that the trip will cost 25,000, right? Then it says how much must she save each month, right, of every month if she's saving account earns her 10.7% per annum compounded monthly, right? So let's write all the information that we have, right? So we have the following. So we see the fact that here we're going to have X, we're going to have I, right? It's N, it's M, then it's F, right? So let's read the information. It says it is planning, yes, to Canada itinerary. So let's go to the cost. Then he says he expects, he expects the trip to cost 25,000. So F is going to be equals to 25,000. Right? Then M here, it's compounded what? We know the fact that this is compounded monthly. So we know that M is going to be equals to 12. Then N, right, is that she's saving for the next 2 years. Do you see the fact that there is planning to take a trip in the 2 years' time? So the time period to save is going to be 2 years, right? And the interest here is going to be what? 10.7. So it's going to be 10.7 divided by 100, which is going to be the same as what? As 0.107, right? And then it says what? The question says how much might she save each month, each and every month, right? To basically with this interest rate. So we know the fact that we're looking for monthly payments. So that's what we're looking for, right? So first we're going to write the formula for the future value. So it's going to be F is equals to X, open bracket, then it's going to be 1 plus, then it's going to be I divided by M to the power Y to the power N, multiplied by what? Multiplied by M, then this is going to be minus 1, right? And this whole thing is going to be what? It's going to be I divided by M, right? So now what I'm going to do before substituting, I'm going to just make what? I'm just going to make X the subject. So I'm going to take this I divided by M and multiply it with F. So it's going to be F multiplied by I divided by M. It's going to be equals to X. Then open bracket is going to be 1 plus I, right? Divided by M, then it's going to be N divided by M, then it's going to be minus 1, right? Then take this, divided the square bracket divided on the other side, so it's going to be F multiplied by I divided by M, and this whole thing, big thing, so square bracket, so it's going to be 1 plus I divided by M, F. So it's going to be what? It's going to be M here, right? Then this is going to be to the power N multiplied by M minus 1, right? And this is going to be equals to X. So now we know the fact that X, let's start substituting. We know that X is equals to, F is what? Is 25. We know the fact that this is multiplied by I. I is what? It's 0.107, right? Then M is equals to what? Is 12. And that whole thing is divided by what? It's divided by 1 plus, what's I? I is 0.107, right? And that's going to be divided by what? Divided by 12, which is M. And this is to the power Y to the power 2, which is N multiplied by 12. And this is minus 1, right? Then when you punch that into the calculator, you're going to get the fact that the monthly payments that Riri needs to make is the following. It's going to be 938. 8.80. So this is the monthly payments that she needs to make so that she can go to the trip, right? So that's the monthly payments. So now we're going to do example 4, which deals with what? With sinking funds. So it says Vilaka's Couriers Company buys a delivery truck for 296,000, right? Then they say the value of the truck depreciates on a reducing balance, right, basis at 18% per annum, right? The company plans to replace this truck in 7 years' time and expects the price of the new truck to increase by 9%, right? So now the first question says calculate the book value of the delivery truck in what? In 7 years. So here, let's look at the information that we're given, right? So we see the fact that the truck, the initial price of the truck when it was bought is what? It's 296,000, right? That is the value of the truck when it was bought back then in 7 years ago, right? So that's what we know, that the value of the truck, right? Then that's 7 years ago. What you call this? No, that's not 7 years ago, right? It's that the truck now when we buy it, it's 296,000, right? So that's the value of the truck. Now we know the fact that the truck, right, depreciates using what? The reducing balance, meaning it's the one with what? Meaning it's gonna, which was depreciate using this formula. Remember, the one that looks like a compound. So it's gonna reduce using this formula, right? So that's how much it reduces. And it reduces by what? By 18%. Do you see that? By 18% per annum. So I here from the depreciating is 18%, right? So to answer the first question before we continue, is that we're looking for what? The book value of the truck in 7 years, right? So let's write all the information we have. We know the fact that we have A, we have P, we have I, then we have N, right? We're looking for the book value in 7 years. So we're looking for the book value in the future. So A is the one that's missing. P, right, is the value of the truck now, which is going to be this value, which is 296,000 Rand, right? I is what? I is the interest rate of that, what you call this, of the reducing balance, which is 18%, which is going to be what? Which is going to be the same as 18 divided by what? By 100, which is going to give us 0.18. Then N is going to be what? The 7 times. So it's going to be in 7 years. So it's going to be 7 years period, right? We want the value of the truck in 7 years time, right? So that's the information that we have so far, right? So now what we're going to do is we're going to substitute this here, right? So this is for number 1. So we know that A is equals to P open bracket 1 minus I to the power N, right? Substitute everything. It's going to be what? It's going to be A is equals to 296. And it's going to be 1,000 here. So it's going to be 1 minus what? 1 minus 0.18 to the power what? To the power N, which is going to be 7, right? So now, paste this into the calculator. We know the fact that A is going to be equals to the following. It's going to be 73,000, right? 73,788 and 50 cents. So this is how much the truck will cost in 7 years' time, right? So we have calculated the book value of the, what you call this, of the truck in 7 years. Book value, right? It means the fact that we're calculating the depreciated value, right, of whatever item that they gave us, right? Then number 2, it says determine the minimum balance, right, of the sinking fund in order for the company to afford the new truck, right? So we need to calculate the amount that it's needed for the, what you call this, for the company to basically afford the new truck in what? In 7 years' time, right? So here, what we're looking for, we're going to basically compound what? This amount, right? So it's going to be what? It's going to be this 260, right? Then we're going to compound it by 9, right? So it says, let's go back and like see why I'm saying that, right? Let's just go back. I'm just going to change my highlighter so that I don't confuse you guys. it says we're done with the first part, right? It says the company plans to replace the truck in 7 years' time, right? And expect the price of the new truck to increase by what? By 9%, right? Annually by 9%. So we see the fact that the company expects to basically buy the new truck, and they expect it to what? To increase this price here, to increase by 9%, compounded annually. I hope that makes sense, right? So we're going to use the compound interest right here. So we're going to use this formula here. A is equals to P, right? Because we're looking for the future value of the new truck, right? So it's going to be P plus I to the power n, right? So here we're looking for A again, right? So it's going to be A. So what was missing? P, we know the fact that it's going to be what? It's going to be the price of the truck now, which is going to be 296,000 Rand, right? Then I here, remember the fact that the truck is expected to increase by 9%. That's going to be our interest. So it's going to be what? It's going to be 9 divided by 100, which is going to be equals to 0.09. Then remember the fact that it's in 7 years' time, so it's going to be n, right? So n is going to be 7. So now let's substitute everything that we have. So it's going to be what? It's going to be A is equals to what? It's going to be P, open bracket, it's going to be 1 plus I to the power n, right? So it's going to be what? It's going to be A is equals to 296,000. Open bracket, it's going to be 1 plus. Then it's going to be what? It's going to be 0.09 to the power y to the power 7. So this truck is expected to cost in the next 7 years. This is how much the truck is going to cost. It's going to cost this amount, 541,099.58. So this is the amount of the new truck in 7 years. This is how much it would actually cost, right? So that answers this, which was the second question. Now we move to this third question, right? It says, calculate the required, right, monthly deposit if the sinking fund earns an interest of what? Of 13% per annum compounded monthly. So now we already know how much the truck costs, right, in the future, right? Now we need to create an investment account, right, to calculate, and that investment is what? Or that sinking fund is called the sinking fund, right? It's costing us 13% per our compounded monthly, right? So we need to know how much we need to pay, how much monthly installments we need to pay so that we can basically raise up this new value, right? I hope this makes sense, right? But first is that what we need to do to get this, already remember the fact that what happens is that with the sinking fund, right? So let me just take my highlighter just to explain it. Let me take the blue, right? So what happens is that we already know that our car is going to depreciate by this amount, right? So what happens is that when we set up this sinking fund is that we know the fact that the car that we bought now is going to reduce by this amount, right? Then what's going to happen is that the future truck that we want is going to cost this amount, right? Then what we're going to do is that we're going to take the difference, right? Because of already we're going to deposit the 73,788, right, into the new car, right? So we're going to take the difference of this two. Then the remaining amount is going to be the one that we create a sinking fund for. I hope that makes sense, right? So, and that sinking fund is going to have 30% per annum compounded monthly, right? So now we need to take from the difference of the two how much we're going to need to save monthly for a period of 7 years so that we can cover the new truck, right? So first we need to find the difference, right? Because we're going to deposit the 75,000. So what we're going to do is we're going to calculate F. So F is going to be the difference between the two. So it's going to be 541, then it's going to be 099, right? And it's going to be 58, right? And that's, let me just do this because we're not going to have space. Okay, let me just erase this. I need space. So it's going to be what? I'm just going to do it here. So number 3 is going to be what? The difference, right? So the future value, the one that we want to basically create a sinking fund for, is going to be equals to what? It's going to be the price of the new truck in the future, which is going to be 541 099, comma what, comma 58, right? Minus the money of the what, of the value of the new truck, right? Of the truck that we already bought, right? Minus that value. So it's going to be, because of this value, why are we subtracting it? Because of, we're going to deposit it into what? Before we create the fund, we're going to take this amount and deposit it first, right? So it's going to be what? It's going to be minus 73, then this is going to be 788, right, comma 50, right? So if here is going to be equals to what? It's going to be equals to that difference, which is going to give us what? It's going to be equals to 467, right? Then this is going to be 311,08. So this is the amount of money that we need to save up from now till 7 years till we buy the new truck. So this is the amount that we need to save up. This is the amount that we're going to create the sinking fund for. And the reason why, again, I subtracted this one is because of, by the time we reach 7 years, since our truck is going to lose its value and it's going to become this price, we can sell the old truck and get this amount and basically add it to this amount. And since we need, what you call this, then since we know the fact that the new truck costs this amount, I need to know what is the difference so that I can know how much I can save up so that I can afford the new truck. I hope I'm making sense. I'm not confusing anyone, right? So with that said, right, with that out of the way, we know the fact that if the amount that we need to save up is this 467,311,08, right, is that we need to know how much monthly installment we need to pay, right? So we're going to use the future value formula to basically calculate for that. So I'm going to write my formula already. X, right, is going to be equals to F multiplied by what? By I divided by M, right? And that whole thing is going to be divided by what? Divided by 1 plus, then it's going to be I, M, then this is going to be what? This is going to be N multiplied by M, right, minus 1, right? I'm going to write all the information we have here. X is what we're looking for, right? Because I want to know how much I need to save up. Then I, the interest rate is going to be what? It's going to be 13, the one that I highlighted in blue. So it's going to be 13 divided by what? By 100, which is going to be equals to 0.13, right? Then in here, right, it's 7 years because of that's when I'm going to buy the new truck, right? Then what's going to happen is that M, since it's compounded monthly, this is the monthly installments that I'm going to make. So it's going to be 12, right? So this is all the information I have. So it's going to be X is equals to, then F, remember, is this one, right? So it's going to be 467,311,08, right? And that's going to be multiplied by I. I is going to be 0.13. And this is going to be divided by what? This is going to be divided by 12, right? And this whole thing, right, is going to be what? It's going to be 1 plus what? 0.13 divided by what? Divided by 12. Then this is going to be to the power what? To the power n, which is 7 multiplied by 12, right? And this is going to be minus 1, right? Paste this whole thing into the calculator. It's going to be X is going to be equals to what? To 3,438,77. So starting from the time they buy the new truck, right, is that they need to save up 3,438,77 so that they can afford the value of the new truck, right? So they can afford the new truck when they replace it in 7 years. So I hope that makes sense with how to deal with sinking funds. So now we're going to move to present value. I don't know whether I said it. Future value, as you can see from the name, is we're dealing with the investment, right? It's investment, it's sinking funds, it's all that, right? It's money that you save up to buy something, right? Present value, we're dealing with loans. So anything that has to do with loans, it has to fall under present value, right? So with present value, the formula is this, what you see. Then the X is the same thing. It's going to be the monthly payments. Then I is going to be the interest rate. Then N is going to be the time in years. Then M, as you know, the fact that it's annual, have annually, as you know the drill, right? But now we're going to do what? We're going to do a question that deals with what? With present value, right? It says Andrew takes out a student loan for his first year of civil engineering. The loan agreement states that the payment period, right, is equals to 1,5 years for every year of the financial assistance granted, and the loan is subject to have an interest rate of what? Of 10.5 per compound monthly, right? So the first thing it says, if Andrew pays a monthly installment of 1,446.96, calculate the amount of the loan, right? So if he pays this amount, which is going to be X, what is going to be the amount of the loan? So let's do that, right? So we see the fact that we need what? Let's write the information that we're going to need. It's going to be X here, so it's going to be number 1. X here is that if he pays monthly installment of this amount, so it's going to be 1,446.91, right? Then we're going to need I. It says this one is compounded what? It's 10.5 compounded monthly. So we know the fact that's going to be 10.5 divided by what? Divided by 100, which is going to be the same as 0.105, right? Then we know the fact that N here is going to be equals to what? N here is going to be equals to a period of 1.5 years. So it's going to be 1.5. Then M here is compounded what? It's compounded monthly. So you see the fact that this, right? Okay, this is compounded monthly. So we know the fact that this is going to be 12 here, right? And P is the one that we're looking for, because we're looking for the, the loan amount, which is the loan amount is actually the present amount, right? So let's take the formula. So it's going to be P is equals to what? Is equals to X. Then this is going to be 1 minus, then it's going to be 1 plus I to the power M, right? And this is going to be negative N multiplied by M, right? And this whole thing is going to be divided by I divided by M, right? Substitute everything. Is going to be P is equals to what? It's going to be 1,446.91. Then it's going to be what? It's going to be 1 minus, open brackets, going to be 1. Then it's going to be plus what? Then it's going to be 0.105, right? Divided by 12. Then this is going to be to the power negative what? Negative 1.5 multiplied by 12, right? Then this whole thing is going to be divided by what? Going to be divided by 0.105, and this is going to be divided by 12. Paste it into the calculator. You're going to find that the present value or the loan amount is going to be equals to what? It's going to be equals to 24,000. It's going to be equals to 24,000. 14 cents, right? So this is going to be how much the present, the loan amount is going to cost, right? So now, number 2, it says determine how much interest Andrew would have paid on the loan, right, on the student loan at the end of 18 months, right? So here do you see the fact that they actually changed our end? They want us to calculate at the end of 18 months, right? And since, very important, and I'm just going to emphasize this, right? Since they gave us in terms of 18 months, right? We do not need for n, we do not need to multiply by this m, because of this m changes years into months. That is why it's called compounded monthly. But since they gave us already in months, we don't need to change our n into what? Into months, because of it's already in months, right? This m converts the months, the half yearly, right? It changes that. But since it's given in months, we don't need to multiply it by 12 because of it's already in months. I hope that makes sense, right? So now, with that said, right, is that to calculate the interest, we need to do the following, right? So in 18 months, actually, if you say 1.5 multiplied by 12, fun fact is 18 months, right? So here they just tricked you guys, is that it's going to be, if you take this in, right, and multiply it by what? By 12, it's going to give you 18 months. So this and the 1.5 years is the same thing. So they could have said the fact then, determine how much the interest Andrew would have earned in 1.5 years, right? So always confirm, is this 18 months and 1.5 the same thing, right? This 18 months and the 1.5 years the same thing. So since it's the same thing, is that we need to calculate the interest, right? First, before we calculating the interest, we need to calculate how much, how much monthly installment was paid, right? So the total amount that was repaid without the interest, right? So we're going to say the total first, the total amount repaid, right? So for loan. So that's going to be equals to what? Remember the fact that it's the one that does not have the interest. So it's going to be the monthly installment. So it's going to be the 1,446.91, right? Multiplied by what? Multiplied by the 18 months, right? So that's going to be equals to what? Remember that 18 months is the same as 1.5 years. So when you do that, you're going to get the fact that the amount that, he paid without interest, it's going to be 26,044 rand. So let me just do this. And 44.38. Right? So now we need to calculate how much interest, right? So the total interest, total amount of interest is going to be this amount. So it's going to be this 26,000, 38 minus the 24,000, 14. Pass that into the calculator. You're going to get that the interest that was paid is going to be 2,044. 38 cents. So 38 cents. So that's the total interest that was paid. So let's do example 2, right? It says Andilia wants to buy a small wine farm that is worth 8.5 million. He plans to, he plans to sell his current house for 3.4 million, right? Which he would use to deposit for the purchase of the new farm. He secures a loan with HBP Bank with the replacement period of 10 years, right? And the interest for the loan is 9.5% compounded monthly, right? So the first question says calculate the monthly, which was the monthly repayment, right? So that's like the monthly installment. So let's read the question and answer what we have, right? So I'm going to write all the information that we need. So we see the fact that for number 1, we're going to have the following. We need the monthly installments. We need I, right, which is the interest. We need N, we need M, and we need P, right? So here we see the fact that how much is the monthly repayments, which is the monthly installments. That's what we need, right? I here is going to be what? The interest, which is 9.5. So it's going to be 9.5. I'm just going to change it already. So that's going to be equals to 0.095, right? And here is going to be what? The period that he needs to pay it, which is going to be 10 years. The interest is compounded monthly, so it's going to be multiplied by 12. Then P is going to be the value. But remember one important information. I'm just going to highlight that important information. They said what? They said the fact that the house that he's selling, right, the farm is worth 8.5, right? And he's going to deposit what? Deposit the house that he's going to sell, which is the value of it is going to be what? It's going to be 3.4 million. So the difference between the two is going to be the amount of the loan. So how much he's going to take out, right? So it's going to be 8.5 million, right? Minus 3.4 thousand, right? Because he's going to already deposit the 3.5. So the remaining amount is the money that he needs to basically take out a loan on. So this is going to be equals to what? When you find the difference, it's going to be, he's going to take out a loan of 5.1 million. Because that's the money that he does not have and he's going to need the loan for, right? So now having everything, we know the fact that we're looking for x, so we know the fact that P, the formula, is going to be equals to what? To x, open bracket, it's going to be 1 minus, then it's going to be 1 plus I divided by m, right? To the power n multiplied by m, right? Then that whole thing is going to be what? It's going to be I divided by m, right? We're going to make x the subject, so it's the same as saying P multiplied by I divided by m, right? Taking this to the other side, and this whole thing is going to be divided by this one in the square bracket. So it's going to be what? 1 minus open bracket 1 plus I divided by m, right? And this is going to be n multiplied by m, right? And this is going to be equals to x. So now we know the fact that it's in terms of x, so calculating the monthly installment is going to be x is equals to what? Substitute everything that we have, so it's going to be 5.1 for the principal. The amount of loan that we're going to take out, he's going to take out, so it's going to be 5.1 million. Then that's going to be multiplied by the interest, which is going to be 0,095, and that's going to be divided by what? By 12 months. And that whole thing is going to be divided by what? It's going to be 1 minus, then it's going to be what? Going to be 1 plus, then it's going to be 0. This is negative. Remember the fact that this is negative from here. Don't forget the negative. So it's going to be what? It's going to be 0,095, and that's going to be divided by 12, and to the power negative what? Negative 10 multiplied by what? By 12. Paste this into the calculator. You're going to get that your x is equals to what? It's going to be equals to what? It's going to be equals to this amount, which is 65,992.72. So this is the monthly installments that he needs to make, right? So that's the monthly installments that he needs to make. Then now let's move on to number 2. So number 2, it says determine how much interest Sandile would have paid on his loan by the end of 10 years. So it's like the previous question, we're calculating the interest, right? So we're going to do the same thing. It's going to be what? The total repayment first. So it's going to be the total amount, right? Amount repaid for the loan. So it's going to be the total amount repaid for the loan. Which is going to be equals to what? It's going to be equals to the monthly installments multiplied by what? By the number of years multiplied by the number of months, right? Because we want to convert this into months. That's why we multiply by 12. I hope that made sense. So it's going to be what? It's going to be 65,992.72. Then that's going to be multiplied by what? By 10 years, right? Multiplied by 12. So when you paste that into the calculator, you're going to get the following. You're going to get the fact that it's going to be this amount. So the amount that is paid without so that's the amount that he's going to pay. So it's going to be 130, right? Then now we want to calculate the interest. Remember, so the total interest here. Total amount of interest. It's going to be equals to what? The difference between what? The difference between this one, right, and the actual loan amount, right? So it's going to be 7919130 minus the actual loan that was taken, which is going to be 5.1 million. So now we know the fact that the amount of interest, take the difference, is going to be what? It's going to be 2.9 somewhere there million. So this is the amount of interest that is paid. I hope that made sense. So now let's do example 3, which deals with outstanding balance, right? How to calculate it. So it says a school sells its old bus and uses the proceeds as a 15% deposit for the purchase of the new bus, right? Which cost 330,000 to finance the balance of the purchase. The school takes out a loan that is subject to the interest of prime, right? Which is, I'm going to tell you, prime is basically, it means the fact that it's 8.5%. So if they say the fact that the interest of prime just know the fact that prime means 8.5 plus 1%. So the interest compounded here is going to be 8.5 plus 1%, which is basically 9.5%, right? Compounded monthly, right? It says the repayment period of the loan is 3 years. So the period of the loan is 3 years. The first question says calculate the monthly repayments, right? So now let's write down the information that we need and what we need to calculate. So X is going to be the one. So number one here, X is going to be the one that we're looking for because we're looking for the monthly repayments, right? Then here, P is going to be the amount of loan that we need to take out, right? The amount. So remember the fact that they said what? They said the fact that the school uses the proceeds to pay 15% deposit of the new school bus. And we know that the school bus costs this amount. So we know the fact that the school bus is going to cost 330,000, right? It's going to be 330,000. But from that 330,000, we're going to take out 15% of that amount. So it's going to be what? It's going to be 330,000, right? Multiply by what? By the deposit. That is why we're subtracting it. So it's going to be multiplied by the 15% deposit. So it's going to be 15 divided by 100, right? So the actual amount that they taking out, the school is taking out, is going to be this. Put it into the calculator. So the school is going to take out a loan of 280,000, right? 280,500. So this is the amount of loan that is going to be taking out, not the actual 380,000, because they already would pay a deposit of the actual cost of the bus multiplied by the percentage, which is the deposit. This deposit is the percentage. I hope that makes sense, right? So now, right, as I said, the fact that prime is 8.5, so it's going to be what? Going to be 9.5 because it's added by 1 divided by 100, which is going to be equals to what? Which is going to be equals to 0. It's going to be 0.095, right? So that's our interest. Then we're going to have the following. So remember I that we need N. N is 3 years, right? Then M, it's monthly, compounded monthly. So it's going to be 12 years. So we have everything. So I'm just going to write the formula in terms of X when X is the subject, which is going to be the same as P multiplied by I divided by M, right? And this whole thing is going to be divided by what? By the square bracket, which is going to be 1 minus, then it's going to be open bracket 1 plus I divided by M to the power Y to the power negative N multiplied by M, right? Then this is going to be what? Then substitute. So X is going to be equals to the following. So it's going to be what? 280,500, right? So then this is going to be multiplied by what? That's going to be multiplied by I, which is going to be 0.095 divided by what? Divided by 12. Then this is going to be divided by what? This is going to be divided by 1 minus, then it's going to be 1 plus, then it's going to be 0.095 divided by 12 to the power Y to the power negative 3 multiplied by 12. Then therefore X is going to be equals to what? When you punch it into the calculator, your X value is going to be equals to 8,985,24. So this is the monthly installments, right, for the loan. Then number 2, it says what? It says determine the balance, meaning the outstanding balance of the loan at the end of the first year. So we want to know, remember the fact that the loan is a 3-year loan, but maybe you want to know how much is remaining for you to complete the loan, the outstanding balance maybe after a year. So that's what they're asking, right? Immediately after the 12th payment, right? So now we want to know how much that's remaining, meaning remaining for the next 2 years after the loan is repaid, right, for only just one period of year, right? So I hope that makes sense. So to calculate the outstanding balance, I'm going to call it outstanding. This is the formula for the outstanding balance, right? So it's going to be the outstanding balance, standing balance it's basically going to be equals to what? It's going to be equals to A, right? So it's going to be A, then it's going to be what? Minus what? Minus your future value, right? So I'm going to write down for A the things that you need, and I'm just going to do it in another color. So for A here, right, remember the fact that the formula is what? It's A is equals to what? Is equals to P. Then this is going to be 1 plus I, right, to the power n. So always, we're never going to use the simple interest. We're going to always use the compound. So we need P. So in our case here, P is going to be what? It's going to be actually what? It's going to be actually the amount, this amount, the principal amount, right? The loan amount. That's what I mean, not the principal amount. So P is always going to be the loan amount. So it's going to be 280 in our case and 500, right? Because that's the actual loan amount that you took out, right? And that it's going to be multiplied by what? You're going to basically find how much it is increased. So it's going to be I. It's going to share the same I as this one. So it's going to be 0,095. Then N here, as they said, the fact that immediately in the first year, immediately after the 12th payment, right? So meaning N here, it's not going to be what? It's not going to be 3 years. We're looking for the outstanding balance in the 12th P, which was after the 12th month, basically. So N here is going to be 12. I hope that makes sense, right? So that's how you would calculate your A, right? So with F here, right, your X here is going to be what? It's going to be your monthly installments, right? So it's going to be your monthly installment. So here it's going to be X is going to be your monthly installment. So it's going to be what? It's going to be this 8,985,2, 4, right? Then we're going to need I. It's going to share the same I, which is going to be 0,095, right? Then it's going to be what? It's going to be I. Remember, then it's going to be N. N is going to be 12 months. And remember the fact that M is going to be what? It's compounded monthly, so it's going to be 12. But very important, we're not going to multiply here. This N, we're not going to multiply it by what? We're not going to multiply it by this 12 because of it's in terms of months already, right? Immediately after the 12th payment, which is the 12th month. I hope that makes sense, right? So with that said, let me just find my A and my F here separately. So A here is going to be equals to what? It's going to be equals to the following. It's going to be equals to 280. 500, right? Then this is going to be what? Open bracket is going to be 1 plus what? Plus 0,095 divided by 12 to the power y to the power 12, right? So you're going to get the value there as being the following. So it's going to be 308. Then it's going to be 338,94, right? So here, we're going to calculate it. So the F is going to be equals to what? It's going to be 8, 9, right? It's going to be 8, 9, 8, 5. I hope it fits. 0.25, 0.24. Okay, it's not going to fit. So let me just like drag it here. So it's going to be F is equals to 8, 9, right? So it's going to be 8, 9. 8985,25. Then open bracket. Remember the fact that the formula for this one is going to be what? It's going to be, I'll just write it on top. So it's going to be 1 plus, because I've already substituted. So it's going to be 1 plus, then here's going to be 0,095 divided by 12 to the power 12. And this is going to be minus 1, right? And this whole thing is going to be divided by 0,095 divided by 12, right? Therefore, F is going to be equals to what? F here is going to be equals to what? It's going to be equals to 112,643,79, right? So now substituting what we have, A and F, it's going to be what? Here's going to be equals to 308. Then this is going to be 338,9 24 minus, then it's going to be 112,643,79, right? Punch that into the calculator. You're going to get the outstanding balance is equals to the following. It's going to be 195, and it's going to be 695,15, right? So that's how you calculate the outstanding balance. So just a tip is that with the outstanding balance, right, when you punch in or when you put your information, right, the only thing that changes is going to be the years, because you're finding the outstanding balance, off whatever year that they're going to give you. They could say here within, within 2 years. So meaning it's going to be 24 payments, right? So only your end is going to be the one that changes. I hope that makes sense, right? So that's how you would calculate the outstanding balance.